So let's talk about one application of the validation method in the application of model selection. So we will talk about the basic ideas, and then we will want to go over some case studies. So here is the problem of model selection. Let's consider a set of M models, H1 through Hm, and then these models can be quadratic, can be linear, can be logistic. And then now each model you have different model regularization parameters, and you want to choose a model. So you use the training sets to train, and then you want to find G1 through Gn minus. So these are the hypotheses that can be returned by the different models. And then you evaluate the validation score for each hypothesis that are returned by these models. And then you calculate the unbiased estimate. Because it's an unbiased estimate of the testing error, then you trust this validation score, and then you pick the one that will minimize the validation score. So this procedure seems to be very, very simple. You just start with the model. You start with all the possible models, and then you, from each model, from each hypothesis set, you calculate the best hypothesis from the hypothesis set, and then you calculate the score, and then you pick the one that is the best. Okay, so let's look at the generalization bound of this model selection idea. The idea is very simple. So let's look at how do we actually execute that. So first of all, you start with you have a D. Okay, so you start with this D, and then the D you are going to split it into the training set and also the validation set. You use the training set to look at the hypothesis set. So here you have M different hypothesis sets. Each one will give you a different hypothesis, and then you use the validation set to calculate the score for each of the GMs, and then these will give you different score values, and then you pick the best. Then once you pick the best, what do you do? Well, you go back to the D and then choose the correct hypothesis set, and then retrain everything to report you the GM star. So if you choose GM star from all these M choices, then you're effectively considering the hypothesis sets that consisting of all these M different hypotheses. And so the price that you need to pay when you try to calculate the generalization bound is that then you need to take into account this log M factor, where M is the number of hypothesis sets that you are considering. And so can we use the GM star as the final hypothesis? No, you actually want to choose the M star out of these M hypotheses. And so the ultimate generalization bound of the hypothesis of the model selection problem using the validation, you actually have this log M factor go into the equation. So let's look at a case study where you have a set of, where you have a polynomial, and then you have a set of data points that are generated from this polynomial. And then we want to use a second order polynomial, H2, and then I want to use a fifth order polynomial, H5. I want to run a validation and then pick one that will be the best. So I want to look at this data sets, and I want to split it into the training and testing. Okay, so here is the second order fit, and then here is a fifth order fit by just using all the training samples. Now, let us look at the expected error. This is the outsample error, and here is the case where you always choose H5, and this is the case where you always choose H2. And this is a function of the validation set size. And so no matter what validation set size you choose, because you always choose H2 or versus you always choose H5, this is the expected error. H2 is always better than H5 given the number of training samples that you have. Now, let us split the data sets into two halves as what we are doing in the validation. Let's call the blue dots as the training sample, and then the red dots as the validation samples. Then we use the blue dots to train the green curve, and then we use the red dots to calculate the validation score. Similarly, we will do the same thing for the other curve. We'll use the blue dots to calculate this red curve, and then we use the red dots to calculate the validation score. So this is the curve that will happen when you plot these two curves as a function of the validation set size, k. You have two curves. One is the blue curve, which is the validation of the G minus, and then the green curve is the validation of the GM star. Now, G minus is what? G minus is that among all the choices, now you have two choices, right? You have hypothesis 1, hypothesis 2. You have all these hypotheses, and then you can choose a G star minus. But that G star minus is still calculated using A minus K samples. The GM star says that I'm going to calculate my hypothesis. Not only that, I will use the A minus K samples to train, and then I use the K samples to pick the best one. And then after I pick the best one, I'm going to recycle all my data. And then I want to retrain the entire model. Then that would be my validation, that would be my expected error. So you can see that there is a clear benefit of recycling in the data, especially when you go back to the example here. We only have how many data points? We only have a very, very small set of data points, and therefore when you're trying to do the validation, you are actually using some of the data points, and therefore by recycling, you actually help the problem of minimizing the expected error. So here is a very, very important observation when you are looking at the validation. Validation and the N minus K samples for training, the outsample error actually drops and then rise. And compared to the in-sample error, this is only using a few samples to validate. This gives us a very good estimate of the outsample error, but as K increases, the estimate also improves. And so the outsample error, the expected value of the outsample error drops. But if K is too large, then only K minus K samples they have been used. And so if you go back to this curve here, as K goes big, right? So if you use more and more samples for validation, that means you have fewer and fewer samples for training, and therefore the validation, this M star minus, will go up because you have very, very few samples that can be allocated for training. The green curve does not have this problem because the green curve says that I'm going to recycle. That goes to the point here that if you ever use the recycling of the validation data, that's usually good for you to get the final hypothesis. So now we have gone through this application of how do we select models using the validation approach. Basically, you have all these possible hypothesis sets, and then you run the validation on each of those. Then you pick the best one, and then you recycle. That would be the model selection procedure.